So, what's your name? My Japanese isn't very good, sorry.
Okay.
Very good.
Yes.
Yeah, all right. Fantastic. Our next presenter is Koki Iguma from Ritsumeikan University and Hokkaido University. He's presenting a ISWC note. This is a shorter presentation at 4 minutes entitled Input Interface with Touch and Non-Touch Interactions Using Atmospheric Pressure for Hearable Devices. Thank you.
So now start my presentation. I'm Koki Iguma from Ritsumeikan University, Japan. Now I start my presentation. So hearable device market is growing rapidly, such as AirPods or Google Pixel Buds. However, these are immature and to be used as input interfaces. For example, the force sensor in AirPods restricts the shape of earphone, and capacitive sensor in Pixel Buds cannot be used when wearing gloves. And head movement recognition with accelerometer gives a strange impression to other people. And related research on the facial action recognition based on the ear canal deformation have possibility to misrecognize the unintended movement, such as talk or eat. So in our approach, we propose a touch and non-touch reduction to the earphone using an atmospheric pressure sensor. It is socially acceptable by simple hand movement and small sensor less design restriction and large pressure variation reduce the misrecognition due to unintended movements. And we can use with gloves and non-touch interaction less discomfort caused by earphone misalignment. So the proposed method has two interactions. In touch, the pressure is changed in the ear canal by touching the earphone, and in non-touch interaction, and it's changed by pressing the auricle by the palm. To recognize the press and release, we set two thresholds. PTH is the amount of pressure difference, and to recognize the touch, change over PTH need to be finished within TTH. And assuming that the pressure change is slower in non-touch interaction, this is because the space created by palm is less sealed. So to recognize the non-touch interaction, when change over PTH is finished more than TTH. And then gesture is recognized based on the number and order of presses and releases. So in evaluation experiment, and 5 Japanese males in their 20s participated in the evaluation experiment. They input the 6 gesture patterns shown in the right table, and they performed touch and non-touch gesture 50 times. By conducting a preliminary experiment, we set the threshold PTH to 10, and the elapsed time TTH as 0.08. So first, we show the result for the touch gesture. We achieved more than 83% in all gesture, and in gesture 3, especially quick and press and quick release, we achieved 99% accuracy. So next is the results for the non-touch gestures. We achieved over 80% accuracy in the gesture 2, 3, and 4, and only about 50% in the gesture 1, 2, and 6. So. And discussion. The non-touch gesture creates a space by the palm and press the auricle, so this space has a large air leakage. So non-touch gesture 1 was misrecognized as an extra release, and often it is misrecognized as a non-touch gesture 3. The non-touch gesture 6 could not maintain the pressed state for a long time, and it was often misrecognized as a non-touch gesture 3. So this is in conclusion and end of my presentation. Thank you.